All right, so this is section 3 of chapter 9. And in this section, we will compare within subject designs to between subject designs. So you have this choice in front of you, between or within subjects. And the choice does matter quite a bit. So we're going to discuss some pros and cons of each design, which hopefully will give you some of the conceptual tools for making the decision that is best suited to your particular study. So one obvious advantage that we've alluded to before is that you will need fewer participants within subject design. You get more bang for your participant buck, so to speak. Sample size is important. The larger your sample, the more likely you are to detect an effect if one exists, especially if the effect is subtle. And many effects studied by psychologists are fairly subtle. So if you decide that you need 30 people per condition, and there are ways of estimating approximately how many people you will need, how many participants you will need. Well, in a within subject design, that means you need a total of 30 people in the entire study, no matter how many conditions you have, because the same people go through all your conditions. Whereas in a between subject design, if you need 30 separate people per condition, that's going to be, with 3 conditions, for example, that's going to be 90 people total in your study. So 3 times more people that you have to recruit. So it's more work, it's more data, it's more expensive, it's more time consuming, and it's harder if you are working with populations that are rare or difficult to recruit. For example, twins, or older people, or individuals with some rare condition or life circumstance. All right, so that's one advantage, is sample size. The next advantage is that within subject designs eliminate the confounding variable of individual differences, which is a primary concern for between subjects designs. So recall, with between subjects designs, if your groups differ in characteristics like intelligence or age or personality, these differences can confound the treatment effects. And we've talked at length about this. Now, in within subject designs, it's the same people who are used in all of the treatment conditions. So individual differences do not vary between treatments. I mean, yes, the same person may undergo some changes from one condition to the next, and we discussed this in some detail, but it's still the same people in all groups, so the problem of individual differences is eliminated. So to further demonstrate this point, let's consider this hypothetical data set. Well, actually 2 data sets. So we have A, which is a between subject design with 3 separate groups in 3 treatment conditions. And B, which is a within subject design, so one group will undergo all 3 treatments. And the names are printed here so you can see that in B, it's all the same people in all 3 treatments, and in A, it's all different people in each of the treatments. Now, what you'll notice is that the means and the scores are the same for all 3 treatments in A and also in B. So the data are all the same. The only difference is that in A, the data come from 3 different groups of people, and in B, they come from the same group. And looking at the means, we can see that there appears to be a difference between the means across the three treatments. So a mean of 45 in treatment 1, 41 in treatment 1, 45 in treatment 2, and 49 in treatment 3. So treatment 2 produces a stronger effect than treatment 1, and treatment 3 produces a stronger effect than both treatments 1 and 2. Now, in the between subjects version of the experiment, one possibility is that the differences in means are caused by the different treatments, which is what you want to conclude. However, the other possibility is that this difference is actually caused by individual differences. So let's say that you are measuring problem-solving abilities. It could be the case that people in treatment 3, Beth, Bob, Don, and Zoe, just happen to be better problem solvers than the other people. And their superior performance is unrelated to whatever it is that you're manipulating. Calming music, whatever is happening in treatment 3. But of course, in the within subject version, we can rule that possibility out because it's all the same people in all 3 treatments, so that concern has been eliminated. Now, another issue is the following. In a between subject design, individual differences are part of the overall variance, making it harder to isolate the effects of the treatment. Whereas for a within subject design, individual differences can be measured and removed from the overall variance, making it easier to detect the effects of the treatment. Let me try to illustrate what I mean. So here, for example, if you look at the within subject example in B, you will notice that Mary's score is consistently higher than John's in all 3 conditions by approximately the same amount, by about 10 points. And Bill's score is consistently higher than Mary's in all 3 treatments by approximately the same amount. And Kate's score is consistently higher than Bill's in all 3 treatments by approximately the same amount. So what this allows you to do is it allows you to decouple the individual differences from the data and, in a sense, remove those differences. And this reduces the variance within each of the treatment conditions, making the effects of the treatment much easier to see. So for this reason, a within subject design is generally more powerful than a between subject design because it reduces the variance and increases the likelihood of detecting the effects of the treatment if the treatment has any effects. So here in this table, we have the same data set, the within subject design that we saw in the previous slide, so the same individuals. But now in this version, you have removed the individual differences from these treatment groups. How do you do that? Well, what happens is, for example, John is consistently 20 points below average. So you add 20 points to John's scores to make him more average. And Kate is consistently 20 points above average. So you remove 20 points from her scores to make her more average. And you do this for each individual, and as a consequence, you can see now the scores are very similar. You have removed a lot of the variance within each treatment that was caused by the individual differences. And now, as a consequence, it becomes much easier to see the effects of the treatment. And so here on the left, this is what the data looked like before this operation, where you're plotting treatment 1, 2, and 3. And here, it's very difficult to see the differences between these treatments, between these conditions. But here below, we're showing the data once this operation has been conducted, and suddenly you can clearly see the differences. You can clearly see that treatment 3 results in higher scores than treatment 2 and treatment 1, and the difference between 1 and 2 is clear as well. So again, in a within subject design, you can remove the individual differences, which reduces the variance within the treatment conditions, making it easier for you to see the effects of the treatment. So remember, research, like life, is all about trade-offs. And while within subjects designs offer a number of advantages, they also present specific challenges and disadvantages that the researcher has to consider. And we discussed some of these in past lectures, so this will be partially a review. One disadvantage has to do with time-related factors. Participants may become tired over time, affecting their performance. External conditions like weather changes can impact people differently at different times. And of course, all of this poses a problem for the internal validity of a study. And also, there's the problem of participant attrition. And this refers to the loss of participants over the course of a study. Now, this reduces sample size and may also create confounds. For example, there may be non-random reasons for why some people drop out and other people remain in your study. So what if it's the case that only the most committed people remain in your study? Well, that changes the composition of your sample, and suddenly your sample may become less representative, which threatens external validity. So in choosing within or between subject designs, there are factors to consider, and specifically we'll talk about 3 factors. Those are individual differences, time-related factors, and participant number. So those considerations are summarized in this table, and let's discuss them in the context of within and between subject designs. So first, individual differences. Individual differences are going to be a bigger problem for between subject designs. They are always looming over your shoulder because you're comparing groups comprised of different individuals. Now, in within subject designs, obviously that issue is eliminated because it's the same group of people compared to the same group of people in your different conditions. Also, within subject designs reduce the variance, increasing the likelihood of detecting the effects of a treatment if the treatment has any effects. And so within subject designs are preferable if large individual differences are expected to occur. Next, you have the issue of time-related factors and order effects. And so this is going to be more of a problem for within subject designs because time-related changes and order effects can, as we talked about, distort your results. And this is especially the case in situations where a particular treatment has lingering effects that contaminate subsequent conditions. Now, when using between subject designs, this issue is largely dealt with because one group of people only runs in one of the conditions, and each condition has its own separate group of individuals. So between subject designs are going to be more suitable when you have treatments that are expected to produce long-lasting or lingering effects. And finally, you have the participant number. So as we talked about, within subject designs require fewer participants because the same group of people will go through all of the conditions in your study. And so this is preferable, especially in situations where the population you are studying is maybe difficult to recruit. And finally, we'll briefly mention another approach that seeks to have the best of both worlds. The advantages of within and between subject designs while minimizing the disadvantages of both. And this audacious approach is called the matched subject design. Now, a matched subject design uses different groups for each treatment, like a between subject design, but tries to match individuals in one group with individuals in another group based on specific relevant variables. So to create groups composed of very similar individuals that are matched. So for example, in a study comparing methods of teaching mathematics, let's say, maybe students are matched based on their math achievement scores. So for every student with a particular math achievement score in one group, in another group, there will be a student with the same score. Okay, that's the idea. So if Tim and Susie have identical math scores, Tim might be assigned to one teaching method and Susie to the other. Now you can match on multiple variables, but this quickly becomes very, very challenging as the number of variables increases. All right, that concludes section 3. And in the next section, we will discuss the statistical analyses of within subject designs.